Hello, this is part of the Controlled Environment Plant Production Engineering/Technology Education modules that were developed and presented by The Ohio State University, Rutgers University, and the University of Arizona, with support from the USDA NIFA program. This module deals with greenhouse location and structures and is presented to you by A.J. Both at Rutgers University and Jean Giacomelli at the University of Arizona. The learning objective of this module is that by the end you should be able to identify the different styles of greenhouse structures in use around the world. Additional resources that might be useful are the American Society of Agriculture and Biological Engineering practice standards, engineering practice 640 and as well as 406 perhaps, and the book Greenhouse Engineering by Aldrich and Bartok. Before you start thinking about a greenhouse structure, you need to go through lots of thinking and preparing yourself, and some of the issues that you need to deal with and need to resolve are listed on this slide. First of all, you need to work on a business plan, because very likely you will need to get funding for your project, and one of the first things that any funder will ask for is, what is your business plan? So a business plan is really critical in the process before you start thinking about construction. You need to have an idea of how you're going to finance your construction. So again, who is going to provide the money, what kind of interest rates are you going to have to pay, etc., etc. Marketing of the product that you produce is really, really critical, because if you grow a very good crop but you can't sell it, you're not going to make a profit and you're not going to be in business very long. So you need to think about the different crop varieties, the different types of growing systems you need for them. You need to think about scheduling, especially when you're growing crops for special holidays like Mother's Day or Valentine's Day. You need to figure out what your clientele is, who you're going to sell this product to, and how you're going to approach that clientele, how you're going to make them aware of your product, and how you're going to make them interested in your product. Labor is very critical. The greenhouse business typically requires extra labor during periods of time when you're sowing or when you're harvesting, and so you need to make sure you have a plan for how you're going to staff all the positions that are needed to run your business smoothly. You need to worry about local laws and regulations. They can vary from state to state or from county to county. You need to, of course, worry about federal regulations. You need to have a full understanding of what impacts your business and what kind of practices you need to follow in order to stay within the law and follow all the regulations. You need to have plans for contingencies. What are you going to do when there is a utility failure, when the power is out for an extended period of time? What kind of pest and disease management strategies are you going to follow when you do get pests and diseases in your operation? You also may want to think about future expansion. Many businesses start small, and once they get successful, they want to expand. And if you have already thought about expansion and worked it into your plan, it becomes much easier and also less expensive to expand. And there may be lots of other reasons because of your local situation and your personal circumstances that you need to worry about. So before you even think about construction, you need to go through a long thought process. You need to address all these issues that I've indicated here to make sure that you start off on the right foot. As in real estate, greenhouse siting is all about location, location, location. You need to think, for example, about access roads. How do you get product to your facility, and how do you ship your plants or your products to your ultimate buyers? You need to have utilities on site, gas, electric, water. And if they're not on site, you need to bring them to your site, and if it's far away, that can be very expensive. You need to worry about permits, local permits, regional permits. You need to think about planning. You need to think about how your construction is going to take place and which different trades are going to be part of the construction process, and how can these different trades like plumbers and welders and such, how can they work together to make sure that the whole construction process runs smoothly. So a lot goes into this whole process. So let's look at some of the different greenhouse designs that we can find if we look at greenhouse production systems around the world. The first one that I want to mention, and perhaps not very well known in North America, but certainly well known in China, and this is probably the system that is most widely used around the world, is the so-called Chinese solar greenhouse. It's a relatively simple structure that uses no additional heating, is typically oriented south with a very thick and heavily insulated north-facing wall. And the idea is that during the daytime, light can freely penetrate into the structure, and the light also heats the heavily insulated north-facing wall, so that absorbs a lot of heat during the daytime, and at night, when the greenhouse cover is insulated by unrolling blankets or biomass like straw materials are placed over it, that heat that was stored in the thick wall is slowly released and is able to maintain adequate temperatures during the nighttime period without having additional heating in the greenhouse. So we would typically consider this a relatively low-tech approach, but it can be highly effective for growing with minimal energy inputs. In North America and in Europe, we have seen a significant increase in interest in the so-called high tunnels. And here you see an example of a small high tunnel used for growing vegetables. These are very simple structures, typically a single layer of polyethylene film. We use roll-up sides for ventilation, and we also don't use any additional heating in these structures. We do need, of course, as in the Chinese solar greenhouse, we do need a source of water to irrigate the crop. But other than that, it's basically a shelter that allows us to start production a little earlier in the growing season and extend the growing season a little bit later compared to field production. And those extensions allow us to make a little bit more money in a system like this compared to a field production system. And as you can see, we can use these kind of systems for year-round production as well. Here you see an example of a snow-covered high tunnel in Pennsylvania with a crop inside. So if you manage these systems well, despite cold conditions, and of course using crops that are able to survive in colder conditions, you can use these structures year-round without having any supplemental heating. We can also use gutter-connected versions of these high tunnels. Here you see an example of gutter-connected tunnels used for an asparagus production in the Netherlands. And we can use them for a variety of crops, but of course we are trying to reduce the amount of structure and the amount of surface area needed to cover our growing area. By adding or by using gutter-connected systems, we reduce the surface area, and it makes it cheaper and also easier to maintain conditions underneath. Another typical form of greenhouses are hoop houses. They come in different designs. Some have rounded, arched roofs. Some have more peaked or Gothic designs. The rounded roofs are somewhat problematic in areas where you have a large snow load, because it's not so easy to get the snow off, particularly the flatter part of the roof. And hence, in those areas, we typically build more Gothic-shaped or arch-shaped structures that allow the snow to slide off a little easier. But these, again, are relatively inexpensive structures, typically covered with double film that we inflate. We do the inflation to add a still layer of air that creates an insulating blanket, so we reduce the heat loss when we do that. And depending on the sophistication, some of these hoop houses have heating systems, have ventilation systems, and are somewhat of a step up compared to the high tunnel systems in the Chinese solar greenhouses I showed you earlier. An example of a gutter connected greenhouse, again we do that compared to the hoop style, the freestanding greenhouse, to try to reduce the total surface area. So in this case it's a heated greenhouse with a ventilation system. We reduce the unit surface area per unit growing space, floor space, and thus we reduce the heat loss per unit growing space, and thus we save energy compared to freestanding houses. Although freestanding houses can be individually controlled, so sometimes it makes sense to have freestanding houses when you grow larger batches of plants that all maintain similar or require similar conditions, then these gutter connected houses can be very effective. We can also use these houses for natural ventilation systems. Here you see a gutter connected house where we don't have mechanical ventilation with fans. We have windows that open up, and the windows are placed strategically in the side wall and in the ridges of the roofs to allow for air to move through. And if you do this carefully, this design, and you place the greenhouse perpendicular to prevailing wind directions, you can still generate sufficient ventilation during most parts of the year. During the summertime, when air conditions are warm and air doesn't move very much, it becomes more problematic. But during most periods of the time, especially when you are in a more windy location, this system works very well to vent the greenhouse. We can also use Venlo style greenhouses. These are typically also naturally ventilated. They have only windows in the roof, so no side windows. And they typically rely on their height, so the stack effect or the chimney effect generates air to rise to the peak to exit the greenhouse. But more so they rely on the wind effect, where wind pressures generated by airflow around the greenhouse and over the greenhouse generate pressure differences that then help move air through the greenhouse structure. So again, if the outside conditions are not too warm and you have sufficient wind conditions around the greenhouse, these systems are very useful for ventilating greenhouses without having to rely on mechanical fans that require electricity to operate and thus increase the energy use of a greenhouse facility. Here's an example of a wide span greenhouse. Depending on the crop you're growing, it can be advantageous to have a larger span greenhouse. Typically that means you go up quite high for the peak height, so there's a lot of air volume in a structure like this. But as you can see in this image, it also creates a very large growing area that may be advantageous for the particular crop that you're trying to grow. An example of what I would call extreme natural ventilation are these open roof greenhouses, a relatively new design where the entire roof opens up, allowing for ventilation. This creates temperatures inside the greenhouse that are virtually identical to outside conditions almost year round once the windows are opened or once the roof are opened. And this is not possible typically with naturally ventilated, otherwise naturally ventilated or mechanically ventilated greenhouses. You need to move a lot of air in those systems to have temperatures inside the greenhouse that are the same as the outside temperatures. But with this open roof design, you are able to maintain temperatures inside that are virtually the same as the temperatures outside. One of the drawbacks of this system is that the vertical roof segments generate shading patterns on the floor, especially when you think about a design that hinges at the gutter, so you have two roof sections next to each other. So sunlight coming in at an angle has to travel through two roof sections before it enters the greenhouse environment. And depending on the width of the shadow bands and the duration of the shadow bands in a particular location, that could be an issue. So the placement of the greenhouse, the orientation of the greenhouse relative to the the path that the sun is traveling through the atmosphere can be important if you are concerned about shadow bands in the greenhouse and the duration of those shadow bands in specific locations. Another open type structure is a retractable roof design that you see in this image. It's a cloth-like material that is retracted most of the time, except during cold weather or heavy precipitation events. It can be closed and protect the crop underneath. So here you see a system like this used at a nursery where the plants are most of the time perfectly happy being exposed to the outside environment, but under some extremer conditions like heavy precipitation or colder temperatures, this structure is used to protect the plants and have them survive throughout the winter period. An example of a typical plug production greenhouse where plugs are grown on benches. The benches are designed so that they fill almost the entire greenhouse area, so the space utilization efficiency is very high. And again, you can see here, this is a gutter-connected Venlo style greenhouse with sufficient height that allows for overhead heating pipes as well as a supplemental lighting system without really interfering with the proper production system for this crop. Some growers that grow bedding plants in the springtime like to have the opportunity to bring the plants to the outside during the days where the conditions favor that process, so sunny conditions where the temperatures are not too cold. And so what they typically do, they grow plants in two layers, one directly on the floor and one on these benches that can then be rolled out to the outside. So in fact, you're doubling the production capacity of your greenhouse space. The challenge, of course, is what do you do during darker days or colder days when you're not possible to bring the plant material on the top layer to the outside. The main reason for bringing these plants to the outside is that they harden off, they get exposed to outside conditions like solar radiation and extra wind conditions, and that makes their survival rate once they end up with the consumer a little bit higher. So bedding plant producers are typically keen on hardening this plant material off because it makes the survival rate higher once the consumer gets the plant material at home and is ready to plant them in their garden. We also grow lots of vegetables. Here you see an example of a tomato greenhouse, a very typical tomato greenhouse system, the high wire system where plants are supported from wires in a large range in Japan. But it could be anywhere around the world. This is a very common system. A hydroponic tomato greenhouse in Belgium is the next slide here. You see different varieties are grown in this system and the plants are grown in troughs in the nutrient film technique system. So the troughs are slightly sloped. Water and nutrients are distributed at the high end, and then by gravity, water flows by the roots to the low end of the trough and is collected and reused for the next irrigation cycle. If you look at this greenhouse carefully, you see it's basically a wall-to-wall operation, so the space utilization efficiency is very, very high. Plants are put in at the far end, and their growth rate coincides with the movement of the plants from the far end to the near end. And this is all done with a mechanical system that moves each of those troughs from the far end to the near end. And then if you time the growth rate with the movement correctly, then you can put your young seedlings in the greenhouse at the far end and you can harvest the mature plants at the near end. And this is exactly what this greenhouse operation is doing. We also use floating systems to grow a variety of crops, typically crops that are not too heavy and not too tall, so lettuces and other greens, including basil, as you see in this picture. The advantage again is that you can move plant material very easily. You can put it in at one end of the greenhouse on these floaters, and you can then push it easily through to the other end of the greenhouse. And if you time the motion of movement again with the growth rate of the plants, then you can put them in at a small size in one end and harvest the mature plants at the other end throughout your system. So it becomes a very easy way of moving plants and a very efficient way of dealing with your plant material while maintaining a very high space efficiency in your greenhouse operation. Another system that some growers are using is aeroponics, where we spray water and nutrients directly to the roots. You see here a system that is partially opened to have you have a look inside. So typically a cavity with spray nozzles is designed and installed, and then plants are inserted in the canopy that covers that space. The roots are inside and are kept in the dark and are then sprayed periodically with water and nutrients so that the plants can grow and mature. Another growing system that some growers use is an aeroponic system. This is a system that sprays water and nutrients onto the roots periodically. The roots are placed in a dark cavity, and so the plants are then able to pick up nutrients and water as needed, and the leaf and the stems are located outside that cavity. This is an orchid greenhouse in Japan. Orchids are grown under low light conditions, and so there are special provisions made in this greenhouse to provide low light conditions, and orchids also like highly controlled temperatures, so there are air conditioning units installed in this greenhouse as well to make sure optimum plant conditions are maintained at all time. Another example from Japan is this vertical system that grows strawberries in 2 layers. I wanted to show this example because it gives you an idea of how this particular grower manages growing in 2 layers. The bottom layer could be tipped and then moved to the top layer. And so plants were continuously rotated from the top layer to the bottom layer so that each of the plants were getting equal amounts of light, ensuring equal growth rates for both the plants on the top layer as well as the bottom layer. Another example of strawberries, in this case in Belgium, where the troughs are raised to make it easier for people that have to walk between the plants and pick the berries. And as well as in this case, the plants are receiving photoperiod lighting to induce the flowering and thus the berry production using LED lamps specifically designed for this purpose. In some cases we grow specialty crops in greenhouse environments because there's a special market for it or because the price is right. Here you see an example of cherries being produced in a greenhouse in Belgium. Other examples are, for example, raspberries in greenhouse structures. Some greenhouses are designed for very special purposes. Here you see an example of a demonstration greenhouse in the Netherlands where they demonstrated the movement of tables to a central irrigation station. So each of these tables was entered into a computer system, and then depending on environmental conditions, particularly solar radiation and temperature, the computer decided when it was time for each of these tables to be irrigated and then moved the table to a fixed irrigation station where water and nutrients were applied to each individual bench, after which the bench was then moved again back into the greenhouse environment. So a highly automated system. In some cases we see very special greenhouse design. Here you see this sawtooth design in Arizona, where we like this particular design for warmer climates where we can use prevailing wind directions to improve the ventilation of these structures. So if the prevailing wind direction in this case is coming from our left and blowing to the right, you can see that the air has to go over the greenhouse roof, and just as it detaches from the peak, it creates this area of low pressure, of turbulence that helps suck out the warmer air inside the greenhouse. So by designing this particular roof structure, we can improve the ventilation in this house and hopefully provide better growing conditions for the plants. In some warm climates like here in India, you can see that the greenhouse is mostly a screen house where inlet openings and outlet openings are heavily screened, and otherwise the greenhouse is more or less exposed to environmental conditions. Not a lot of heating or other environmental control practices are being used, but the screens are obviously important to try to maintain insect-free conditions inside the growing environment. Another shade house is shown here in Florida, where the sides are completely opened, but the roof or the shade screen material is only placed on top of the plant growing area. This is done for two purposes. It helps to reduce solar radiation directly on top of the crop, and it can also help with heavy precipitation, hail and heavy rainfall, preventing any damage from the crop under those conditions. Another different type of greenhouses are greenhouses designed as conservatories, and here you see an example of the U.S. Botanic Garden in DC. And then we have highly specialized greenhouses like the Biosphere 2 in Arizona that was designed to maintain different ecosystems to try to simulate the biosphere as we know it on Earth. So they have areas in this greenhouse facility that mimic tropical environments or more temperate environments, or in this case an ocean environments as is shown in this picture, to try to simulate the interaction of all these different environments as it is occurring on our planet. We also see a lot of interest recently in rooftop greenhouses, particularly greenhouses located in densely populated areas, so as major cities. So here you see an example of a greenhouse installed in Canada on top of a building. Another growing system that has received a lot of attention recently is the vertical farming system, where we are trying to grow plants in major city areas, in areas with high population density. The idea is that we can reduce the shipping distance and we can grow plants at very high densities. So the footprint of a growing system like this is relatively small. We would grow plants in apartment-like buildings at different levels. And the debate has been about whether this is a good idea or not. I have my reservations about this idea, but nevertheless, many people are interested about this and are actively pursuing demonstration projects and installations to demonstrate that this is indeed a viable option for resolving some of the issues of limited accessibility in major cities to food products and plant products, and also reduce the land use required for growing our food. So we'll see in the future where this is all going. We'd like to acknowledge the funding that was received for this effort by the USDA NIFA program.